to announce Dr. Georgios Karagiannis from the Alliance for IoT Innovation, and he will guide us through a lot of issues concerning. Georgios, please go ahead.
Yeah, thank you very much, Mr. Chairman. First of all, I would like to thank the organizers of this workshop for inviting me. As you know, as you have heard, my name is Georgios Karagiannis, and in the context of this presentation, I'm representing AIOTI, that is the Alliance for IoT Innovation. And I am the AIOTI Steering Board Chair and also the co-chair of the AIOTI Working Group 3 that's actually focusing on IoT standardization. I will share now my slide. And at the same time, I will stop my video because I'm working from home and I have sometimes connectivity bandwidth problems. Let's see if can you see my screen? Can you see my screen?
Yes, perfectly. Thanks, Georgios. Okay,
good. So in this presentation, I would like to provide a brief overview of the AIOTI Workgroup 3 IoT standardization challenges and possible solutions. And as you see there, this presentation has been prepared using input from the Workgroup 3 task force leaders. And later in this presentation, you will also see their names. So what I would like to present today is to give you an overview of IoTI, then to give you also an overview of the IoTI Working 3 that's focusing on IoT standardization, then go into the IoT gap analysis and solutions, and then give you some insight on future activities or future vision of IoTI. So let's start with the IoTI overview. So currently the IoTI vision, mission, and founding members, you can see them on this slide. But the vision of IoTI is to promote IoT deployments in Europe by stimulating discussions with relevant IoT stakeholders in the IoT ecosystem and identifying the barriers for such IoT deployments, including barriers in business drivers, standardization and regulation, and providing guidelines on solving them. The mission of IoTI is to focus mainly on 4 main areas. So deployment, to actually identify barriers, including business drivers, standardization and regulation, and provide guidelines to solve them. Then another area is the IoT ecosystem, where SMEs play a significant role in this ecosystem. The third area is IoT uptake, to stimulate discussions on the identified barriers and promoting their solutions. And then on the fourth area, support the European Commission founded large-scale pilots. So these were actually projects that have been funded by the European Commission some 4 years ago, in the context of experimentation and verification of the outputs generated by IoTI. And IoTI has actually 17 founding members and more than 160 members. So this slide shows the structure of IoTI. So it has 12 working groups and 2 large activities. You can also call them working groups to support SME interests and distributed ledger technologies. And then from these 12 working groups, there are 4 horizontal ones that are focusing on IT research, IT ecosystem, IoT standardization, and IoT policies. So as you see there, the working 3 is focusing on IoT standardization. There are also 8 working groups focusing on vertical industries, starting from smart living, smart farming, going towards smart mobility, smart city, and smart buildings. So let's go now through the working group 3. IOTF focuses on IoT standardization, but being an alliance is not working on protocol specifications. So that's, it's not doing some work on protocol specification, but focuses on the identification of gaps, so of challenges related to IoT standardization, including IoT standardization landscape, so providing a landscape of SDOs that are active in this area, IoT architecture, semantic interoperability, IoT impact on 5G, security and privacy. And in addition to the identification of these standardization gaps, this working group is as well providing guidelines on solving these gaps. And in this slide, more details on this working group are provided, including information about the chair, that is particularly myself. And let's continue now with more details on this working group. In line with what I mentioned in the previous slides in the task force leaders, so you see here a lot of all the task forces that I mentioned previously with the task force leaders. And if you want to go into reports, then there's a URL at the bottom where you can go and find all the outputs that are mentioned on this slide. So now I'll go to gap analysis and solutions. The outputs of this task force, so this is a task force in working group 3, provided the output in 2 reports, where the first release was published in May 2018, and the second one was published in January of this year. The methodology followed was done to analyze each of the gaps individually, so each challenge individually, and provide keywords that would help searching for potentially available standards and SDO databases. So if some of these challenges are solved already, then by using these keywords, you couldn't actually find it in this SDO database. For each of these gaps, a short summary of on the status of the gaps is provided in the report. More details on the gaps is provided in the next slide. So you see here a consolidated list of gaps that are shown and worked out in the report. And it shows 16 key IoT standardization gaps that are described in this report. The left column shows the name of the gap, the middle column provides the description of the gap, and the right column the domain that is used. And the listed gaps are related to connectivity, interoperability, semantic interoperability, platform interoperability, safety, solution and software deployment and maintenance tools, device certification, data management, and cyber security. So this slide shows an example of a gap that focuses on solution and software deployment and maintenance tools. So this is somehow provided here as an example to understand how these gaps are discussed in the report. In particular, in this example, the gaps relates to the need of standardized methods to distribute software components to devices across network and platforms. And you can have, it could be anything like airports or other kind of platforms. And so standards are needed to take the context of the users and the customers and other devices into account, while at the same time guaranteeing their privacy protection. So this is a way of how these gaps are described in that report. Then this slide shows some of the mentioned gaps and also emphasize that some of them are already solved. So these are also described in the report, the way how they're solved, and they are shown here in this table using the green color at the left side. You see there green color, and while some other ones are less addressed and or not addressed at all, that's the red color in this table. And then the technical topics are well understood and semantic and platform interoperability is making its way, so it's being addressed. Data security and privacy are well understood, but more work is needed, in particular with all these new types of solutions and enabling technologies that are being used. And more information will be provided in the next slide on this. In addition, it is important to mention that IoT and edge computing convergence can be seen as an open issue, like what Augusto mentioned in his previous presentation. This is very important. It is open issue also from the point of standardization. Moreover, deployment and societal topics need further focus in standardization. So these are also open gaps that are also mentioned in this report. And now, so this was the work that was, that discussed the gaps and the solutions on IoT standardization. Now I'll go through some outputs of another task force that is focusing on the high-level architecture. So the reference IoT architecture that the IoTi has published. The left part of the slide, and this shows us the mapping to the BDVA reference model. So the BDVA stands for Big Data Value Association. The left part of the slide shows one of the key outputs of the high-level architecture task force that depicts the HLA functional model view. It consists of 3 functional layers. So the application layer, Internet of Things layer, and networking. And it includes also at a high abstraction level a number of entities located in each of the 3 functionality layers, and also the interfaces used to interconnect these entities. Things are also being represented in the architecture. Some more details on this layer. So the application layer contains the communication and interface methods used in process-to-process communications. The IoT layer groups IoT functions such as data storage and sharing and exposes those to application layer with APIs. The network layer consists of data plane functions, including data forwarding functions, and as well control plane functions like location and device tracking. The right part shows the BDVA reference model, and it's actually composed by horizontal functionalities and vertical functionalities. So I will not go through all of them, but important to see that the horizontal ones include big data applications and as well data processing architectures, data protection, data management. HPC is also part of that, and as well IoT, cyber physical systems, edge, and fog computing is also shown here as a horizontal layer for the BDVA. And then for the vertical layers, one important point is the big data types and semantics. And they actually came up with 6 types of big data types, structured data going up to the graph data, network, web data, and metadata. And semantics aspects are also included, of data are also included in this model. Then they also have as a vertical functionality standards, communication and connectivity, cybersecurity and engineering and DevOps, and data platforms. So data platform focusing on marketplaces in particular. And the last one is artificial intelligence platforms. So then regarding the mapping, you see here the mapping of the entities that are shown in the left part. Based on discussions that happened or that had been done between the IoTi and BDVA. I will not go through all this, but the mapping is done on this synchronization that has been done between the BDVA and IoTi. So all the the functionalities are placed on the places where without that makes sense. Okay, so now I'll continue with another output of another task force, that is IoT relation and impact on 5G. So this report actually described use cases and defined requirements. These requirements are also used by 3GPP SA1. But in this slide, I'm just showing one type, of what has been shown there. It's just related to to the area of IoT and 5G frequency spectrum, because we have provided some information and guidelines also in the report on this. So the IT technologists are developing and new connectivity protocols and frequency bands are used for implementing the functions provided by IoT communication network layer. A new connectivity based on 5G technologies are expected actually to support applications such as smart homes, smart cities, but as well massive machine-to-machine communications for industrial applications or industrial automation applications. And as the IoT, industrial IoT, and the underlying connectivity technologies aim for worldwide coverage, there is a need for harmonized worldwide frequency bands in order to facilitate global roaming and the benefits of economies of scale. The right of figures shows actually the different types of applications, types defined by that where 5G can be used, like the enhanced mobile broadband, massive machine type communication, and ultra reliable low latency communication. Important to mention, and this is maybe good to emphasize here, that the 5G technologies need new harmonized mobile spectrum, and regulators should aim to make available some 80 to 100 megahertz per operator of the contiguous spectrum in 5G midbands, that is 3.5 gigahertz and around 1 gigahertz per operator in the millimeter wave bands, that is 26 to 40 gigahertz. The lower left figure shows the 5G technology spectrum distributed in 3 key frequency ranges to deliver the required coverage and support different use cases that have different requirements. There are 3 ranges below 2 gigahertz, between 2 and 80 gigahertz, and above 24 gigahertz. And each frequency band, as I mentioned, each frequency band range is optimal for certain application types. And this is described in the slide. The top right figure shows the 5G spectrum targets worldwide and spectrum frequencies for the global harmonization. Now I'll go through the output of Security and Privacy Task Force. So shows that the digital and data are now highly regulated domains. This shows an example of the contextual state of the art privacy and security, and it provides an overview of 50 plus security IoT principles. And note that this work was referenced, is mentioned here also by the European government, such as the UK DCMS, that is on consumer IoT security. And among other, several data-related security and privacy principles are listed. Some of the security principles are data privacy and as well data encryption by design. So the next slide is about digital and data, and that are now highly regulated domains. And you see here a state of play by November 2020. So key information from these regulations is that security and privacy by design and by default principles are needed and required for the complete data cycle. And that is the cycle is generation, collection, storage, access, sharing, retention, strong deletion, and other processing of data. So in all these phases, you also need to have these principles.
Georgios, 10 minutes.
Okay, thanks. The following slide will focus now on the output of another task force, that is semantic interoperability. So why is semantic interoperability important for IoT? Well, the value of IoT grows with the available information. And today there are many heterogeneous IoT scenarios that operate as silos, but where a tight coupling is needed on sharing information, on having a federation across silos, and use of dynamic use of sources. And interoperability is in this type of scenario needed, and 4 types of interoperability can be identified. They have been discussed in several documents. I will not go through a discussion here, but there are syntactical interoperability, technical interoperability, semantic interoperability, and organizational interoperability. And the basis actually for semantic interoperability is the agreement of meaning of information that actually equals to semantics. So let's now go to what are the barriers actually, that to deploy or to use this kind of semantic interoperability principles and concepts. Currently, the semantic interoperability technology is available, and some tools are also available. But however, the main problem is that it is limited to a relatively small community. And there is also some wrong perception that semantic interoperability can be used only by academici and experts, and it's complex. And in order to alleviate these barriers, IOTI working with three worked actually on providing, some guidelines to alleviate barriers and also how to use the technology and make it easier for stakeholders and show actually also best practices. So these stats were published to 2 new joint white papers in October 2019. One of the paper is Semantic IoT Solutions, a developer perspective, where the target group is developers and software architects. And the goal is on how to develop semantic systems and achieve semantic interoperability. So via the URL, you can get the download the paper. And then the second one is towards semantic interoperability standards based on ontologies. And the target group is semantic experts, standardization engineers, and SDOs. And the goal is to how to create standards for semantic interoperability. You could also download the paper via the URL. And note that these 2 papers are referenced in the ISO IC 21823/3, that's about IoT semantic interoperability. It's an ongoing project, and are published on the ResearchGate, so the URLs that you saw there. And it's important to mention that the papers are outputs of the collaboration of IOTI with ETSI, with 1M2M, W3C, ISO, ICGC1. Then some details on these 2 papers. So first on the first one, on the developing semantic solutions. So it provides key aspects and activities when developing semantic solutions. So it starts from semantic modeling, which are the ontologies, and going towards deriving the required information that represents the reasoning. And there are some intermediate steps, ontology instantiation, that represents semantic information, managing semantic information, that represents storage, and accessing relevant information that represents information retrieval. Then a definition of the ontology is provided in a reference. You can find it in the paper. Provide a formal specification of a shared conceptualization by formally defining relevant concepts, the attributes, and the relationship between these concepts. So, and now some more details on the second paper on the interoperability specification. And it shows, this slide shows the difference between interoperability specification, semantic interoperability, and ontology-driven interoperability, where actually in the last one produce semantic descriptions through ontologies. And then this slide provides some more concepts that are described in the paper. I will not go through details, but the concepts are co-creation, separation, and consent. So the way of how you could actually work towards defining this, defining knowledge perimeter, modernization design principles, evaluating usefulness and deployment concerns. And this figure shows actually it's important maybe for the ones that are interested in the cross-domain ontology. So if you have ontologies used in domains, sometimes you need a cross-domain ontology, and this paper describes also the way of how you could do that. Then the last slide is about future of IOTI. So as I mentioned, in the beginning, I mentioned, I provided some information about the mission of IOTI, but for the future, we like to actually do some changes or provide improve the way of how the members, but also the community, could profit from IOTI. So first of all, is it shows the on the left part, it shows the objectives that IOTI will mainly work on and have the ownership, so leadership. So objectives are IoT, industrial IoT application and vertical. So that's already done currently. The vision on IoT and industrial IoT edge computing for the future. So edge computing becomes a very important point. So it's in line with what also Augusto mentioned, that edge computing becomes to be very important. Convergence between IoT and edge computing is also very important. IoT and industrial IoT can be seen as edging for converging technologies, such as connectivity, 5G and beyond 5G, artificial intelligence, edge and cloud computing. So these are the three main things that topics that IOTI will work on and try to have leadership on that. The lower part shows the key contributions of IOTI to external bodies. So provide input to European policy strategies, provide input to standardization bodies. The right top part shows the topics where the IOTI will mainly cooperate and collaborate. So these are contributions and relevant EU funding programs and partnerships. So also research programs and the Horizon Europe partnership, for example. Contribution to European and international dimension, including research and standardization activities. And then the right lower part shows the activities that the IOTI will investigate and share with external parties. So learn, in that phase. Investigating, cooperate on distributed ledger technologies applied to industrial sectors, and as well investigating, cooperating on computing continuum. So, the data connectivity continuum where edge and cloud are very important parts of this. So I'd like to thank you very much. Sorry if I was a bit too long.
Well, thank you very much, Georgios, and sorry from our side that you only have so little time to tell us about so many things that you're working on. We have 1 or 2 minutes for a few questions. I've got one already on the chat. What is the biggest challenge you have right now in adopting the standard?
Yeah, the biggest challenge is that you have too many standards. So they are actually, if you look, for example, to standards that are focusing on platforms or on accessing data, or also on ontologies, that I mentioned. There are several, and the main challenge is to find ways on how they could somehow converge. That's very difficult. But there is, by doing, one of the topics that we work in now is also to identify what will be the ways and how we could discuss with SDOs, working on similar topics, to find a way that will be seen as win-win situation for all of them. That is very difficult to achieve, but one way of doing it is to find, for example, what are the common points of SDOs that are working on the same topic, and by having that, find some kind of minimal interoperability points. We also work on that areas. That's a way of how you could provide interoperability. So finding the minimum interoperability points, meaning what are the key points that one or more type of standards could cooperate together to get at least interoperability on those points. So that's the biggest challenge. Too many standards and find minimum interoperability points to converge between them or to work with it together.
Okay, thank you. And another question, and I would suggest this is the last one because we still have a break for a few minutes. I will read it out from the chat. It's a pretty long question. As you mentioned, importance of industrial IoT, do you consider the mapping to some other manufacturing-related reference architectures, such as the Reference Architectural Model Industry 4.0, RAMI? And second question, no, first, answer the first question. This is two questions. We stop with the first one. I'll read the second one in a minute.
Yeah, I very much agree with that. We have already in the report. So if you look into the HLA report, we have mapping that we did mapping to the IoT reference model, to one NPM reference model, to IAC, to RAMI 4.0, and to the big data value association model. So we have, it's very important. That's why you also work on that.
Okay, thank you. And the second question from the same colleague, how do you consider collaborative aspects regarding semantic information management?
Cooperating method, well, I mean, using semantic, using ontologies, it could somehow provide a solution to that. I'm not sure if I understand well the question, but one important or one difficulty is the situation where you have different domains and you use for a certain domain, kind of ontology, and for another domain another ontology. If those domains, if you have a cross-domain kind of situation, for example, you have the smart mobility domain, automotive domain, and you have the energy domain. Sometimes if you have electrical cars, you need to have a cross-domain type of use case. So in that case, the difficulty is how to use, these two ontologies that are different in these two domains to let them somehow work together. So that was one of the parts that I show with cross-domain ontologies, that it's providing a solution for that. I'm not sure if I answered the question, but in this kind of situation, you could use the cross-domain type of features to solve the multi-silos or multi-domain type of use cases.
Okay, thank you very much, Georgios. I think we stop here. I have allowed a little bit more time for the speakers